Good morning, everybody, and welcome to this webinar, Heat Planning for Cities, as part of the Celsius talks. The entire topic is Heat Planning for Cities, a prerequisite for the energy transition, and it's my pleasure to host this morning session for you. My name is Sophia Lettenbichler, and I work for the DHC Plus technology platform, which is set up under the umbrella of Euroheat and Power, the District Heating and Cooling Association based in Brussels. And the DHC Plus technology platform as such deals with all research and innovation topics related to district heating and cooling. So this morning you can basically participate by writing on the chat during each presentation and also debating with the experts during the Q&A session. Because all participants and basically all attendees are muted during the webinar for functionality reasons. So please feel free to write anything that is not clear for you in the chat function, and we will of course pick up all your questions. So what will you hear today? We have 4 different presenters. Actually, the first presenter changed recently, so we have Serena Pagliulia and Francesca Fasano from City of Lecce, who will basically present how they are involved in the PLANHEAT project. Then we have Bernd Möller, who will speak about the Heat Roadmap Europe project. And Peter Fingerhoots from Vito Energy who will introduce us to PLANHEAT and the mapping heating and cooling demand and low carbon supply sources at city level. And then we have Shabat Oregi from Technalia, who is also involved in the PLANHEAT project. And he will speak about mapping current and future heat, cool and domestic hot water demand at district level. To give you a short introduction about these Celsius talks, as you might know, the Celsius project was a FP7 project running until the end of last year. And the main areas of activity was an innovative demonstration of projects focusing on utilizing waste heat in 5 partner cities. You see all 5 partner cities on the right listed. And there were, at the end of the project, 10 new demonstrators and 20 existing ones. And until the end of the project, there were also 67 Celsius member cities signed up to the project and 68 Celsius city supporters. Plus, there were 5 position papers to influence policy on mainly EU level produced. And currently, there is a consortium of 4 institutions working on the continuations of Celsius 2.0. They are the city of Gothenburg, the Johanneberg Science Park, which is a science park situated in Gothenburg, the Research Institutes of Sweden, and Euroheat and Power. And as part of this, it's our pleasure to now host this webinar for you. Okay, so as I said, the first speakers are Serena Pagliulia and Francesca Fasano, who will introduce us to the idea of heat planning and what it means for cities. So please, Serena and Francesca, the floor is yours.
Yes, good morning to everyone. I can, do you see my screen? Can I open the presentation? No. I'm gonna open the presentation. Okay, this morning it's me and Francesca Fasano that we will present you the situation of heat planning that regards the municipality of Lecce. The assessor that is responsible of this, let's say, office had some problem this morning and probably will join, but we will start. By the way, she sends her regards. And okay, let's start. I would like just to give you a first impression of the city where it's located and the context, I would say, that characterize this town. Firstly, as you know, Lecce is located in the southern part of Italy, and it's in a really, really old city, historical one of. You hear me? I don't know if I have some. Hello?
Yes, we hear you.
Yes, because I don't know why, but they say that the audio was deactivated, that the speech was, I don't know. Okay.
No, it's fine. Thank you.
Okay, so we can continue. Sorry. So what I was saying is that it's 95,000 inhabitants, and the city is located in a particular site because it's in the middle between two seas, the Adriatic and the Ionian Sea, and it's around 238 square kilometers of surface. The climate is typical Mediterranean climate. So I think it's really important, this information is really important to understand the heat source that we can exploit in this context. So what it's important to know is that the main source of heating for Lecce municipality is the methane gas, and we have this distribution system that cover all the city, and many buildings, private one, can also have like some autonomous boiler for the domestic hot water production, and for the cooling, that is the main, let's say energy consumption aspect that regards this this part of the Italy, since we have really warm climate. It's mostly provided by electrical split type air conditioners, and in these last years, we have some private buildings that are starting to install the heat pumps, electrical one, for both heating and cooling production.
And also some municipality building or other public building.
Okay, both private and public buildings. Okay, the photovoltaic systems are really, let's say, useful to have in the both private and public buildings. Okay, as you know, Lecce is involved in PLANHEAT project, and it's the role is mostly to validate the research that we are performing within this project. In particular, Lecce has as main target the development of a smart strategy for collection of relevant data to be used for mapping the heating and cooling demand of the city and supply. It's important to say is that municipality has a big potential of renewable energy sources, and not of them been already exploited, let's say, because what we have it's mostly photovoltaic plants installation at this moment that can produce around that have a total power of around 52,000 kilowatt, and they are installed on a lot of roofs of the building in the city. But what we have are also many renewable energy sources that could be exploited, as of course the solar one for the also domestic hot water production, and biomass, since the agriculture sector is one of the most developed here, and as I said before, that the location of Lecce allow also exploiting the seawater, since we have the coast very close to the city center.
Also the wind.
Yes, and the wind is really important, since it's a very windy, let's say, location. Lecce municipality joined the Covenant of Mayors and developed the SEAP in 2014. In this SEAP, Lecce municipality starts, let's say, providing some target for decreasing the CO2 emissions, and in particular, the main target is to reduce this emission by the 20% until 2020. It's important to say that the data, the baseline calculated for the SEAP is 2007. So in this, let's say, period duration from the 2007 to 2020, that's the target that Lecce municipality would like to reach. And in order to reach these objectives, some interventions have been already planned, some of them also implemented. For example, energy savings in buildings and renewable energy production, exploiting wind, solar, and other energy sources. In the SEAP, we have this, let's say, graph at the baseline. In the baseline in 2007, 256,000 of tons of CO2 emissions have been calculated and produced by different sectors. And here in the graph, you can see the percentage of production of CO2 emissions. We can say that the main sector is the residential buildings. Green. It's in green with the 38%. Then we have also buildings with the 32% for, let's say, other services and sectors, but not residential, let's say. And then we have the transport, mobility with the 24%. And we can say that these three sectors are the main CO2 emissions producing. So that's the target that Lecce would like to reach until 2020, with the 20% of reduction of CO2 emission. And then in this SEAP also it was calculated the percentage, the amount of CO2 emissions that have been also reduced with the installation already done of photovoltaic systems on public building roofs. So we can say that considering this production, this let's say reduction of CO2 emissions, the percentage of the total amount can be in some way a bit more, 20.1, just to be in detail. So in the SEAP, there are some actions that have been highlighted in order to reach this target. In particular, these actions have been divided in 4 sectors. The first one is the public, and the intervention that have been foreseen are the traffic lights with LED, and the use of micro wind turbines of the roofs of public buildings, that at this moment most of them are covered by photovoltaics. And then also the join to the green public procurement for what regards the environment. And then, of course, the more incentive in the installation of photovoltaic panels on the buildings, the left. And then energy efficiency of public buildings with active and passive solutions, and the energy renovation of the public lighting system, also using LED and automatic system of control. Then we have the sector of mobility, and the actions that have been foreseen are the replacement of traffic lights with roundabouts, and then the promotion of electrical vehicle use, the construction of a cycle track and pedestrian one, and the use of electrical public car, and the promotion of natural gas cars in general, also in the private, and the reinforcement of the use of this filobus, that it's an electrical system of transportation that we have here in the city that has been already installed, let's say, that it's activated.
and also better mobility planning for the incentivate the use of public bus.
Okay, yes. And then, of course, for the residential private sectors, possible action is the adoption of the ITAC protocol, that it's a protocol that can allow the and support private intervention of energy refurbishment and sustainability of private buildings. And then, of course, incentivize the use of photovoltaics, since the sun is the main, let's say, renewable energy source that we have. And then also it's really important to make a really, let's say, a plan, a really impressive plan of dissemination in order to involve citizens. And in this sense, Lecce municipality try to activate training activities on sustainable action and energy. Also trying to propose the actions that have been already implemented in the public sector that can be in some way replicated in the private, and also a communication plan in order to share all this information, for example, through the use of open data and website that Lecce already has. Lecce already has an open data platform. We are collecting all the needed information regarding sustainable and energy plan. Okay, that's all. Please, if you have some questions, we are available. Thank you very much for your attention.
Thank you.
Thanks a lot, Sabrina and Francesca. Indeed, if you have any questions, please write them in the chat function of the webinar. Now we will continue with another project, basically Heat Roadmap Europe 4, as a lot of you will probably already know. And Bernd Möller from the University of Flensburg will tell us about one particular part of this project, the Pan-European Thermal Atlas, and how city regions can make use of it. So please, Bernd, I will give you presenter control and then the floor is yours.
Okay, thank you. While I'm waiting for my screen to show.
We already see it, so it's fine.
Okay. Good. Thank you for giving me the opportunity to speak about our Pan-European Thermal Atlas, PETA, and how we can use this in cities across Europe. First, a few words about, my screen is not showing right. A few words about Heat Roadmap Europe 4, the overall aim. We want to identify how 14 EU countries that comprise 90% of the European heat markets cost effectively can decarbonize their heating and cooling sectors. We want to create scientific evidence to support long-term decision making, quantify the impacts of various alternatives, and then empower by means of political advice, but primarily about information, the transition to a low carbon energy system. And then you ask yourself the question, why mapping? First, the way European cities and towns and villages, and we've just seen the example from Lecce, have developed in the past, actually defines what we can do to develop sustainable energy systems today. So efficient and sustainable heating and cooling technologies really depend on how heat demand is located in space, because the distribution and the density in particular of heat demands defines what is possible in terms of district heating, district cooling, and it also defines the access to local renewable energy sources. I'm showing you a very old map, 450 years old, presented by the European cartographer Gerardus McCarter. He lived he's partly Flemish, partly German, and he drew this map based on the knowledge of the world that he had by then. And I'm showing this because it's actually a very good analogy to what we know about the heat demand and the possibilities of developing district energy systems in Europe today. What we see here on McCarter's map is that the map of Europe and part of Asia looks pretty much as we know it today. However, all the parts who have just been developed, who have not been mapped properly, they look a bit strange. And Australia is missing completely. So that means for us, if we talk about mapping, that a map represents the knowledge of today. And learning from McCarter is that we actually can use the map as an encouragement to go out and explore the world. So we should look at heat atlases as a means to exploring the opportunities for future development of sustainable energy systems. In Heat Roadmap Europe 4, which is a series of projects, we want to establish a quantitative and a geographical basis for heating and cooling strategies for the 14 member states. We want to produce a realistic survey of heating and cooling markets, including the economy of solutions and the location. And we want to visualize, by means of mapping, heating and cooling demands and possible supplies. On the course, we actually developed solutions for 3 problems that we'll face in most countries and in most cities and regions of Europe. The first is that high resolution on data on demand and on its drivers is not available. On this map of Belgium, of Brussels in Belgium, we show the distribution of office space buildings, simply because no map that shows the distribution of service sector buildings in particular does exist anywhere in Europe. A solution is for this problem is that we do some geostatistical modeling. We estimate flow areas by multilinear regression techniques using readily available data that we have for all of the EU countries and other countries in Europe as well, land use, population, soil sealing, percentage of buildup, and so on, to form hypotheses, such as that the service sector floor area is primarily located in urban centers. And then we do a series of multiple linear regression analysis where we do, for example, neighborhood statistics of buildup, of soil sealing, etc., in order to make a curve fit with data that shows us how the likely distribution of floor areas is on the basis of the known data. The second problem that we want to look at is we do not know our heating and cooling markets. So particularly for Europe, and this shows a map of Berlin. Okay, we can now map the heat demand densities using our statistical methods, but how should heating be provided? So in order to know these markets, we need to develop a little more, and the solution could be to connect demands and costs and connectivity. This example from Finland shows where we could develop district heating systems on the basis of coherent and contiguous heat demands. So here we describe on the basis of heat demand densities areas that are connected and that could be interconnected with district heating systems. And then on the diagram you can see a supply curve, how cumulative heat demand develops and how the average distribution capital cost develop. So if you want to look at a threshold of 5 or 6 euros per delivered gigajoule per year, and it is an investment cost, an annualized investment cost, then you can separate the economic potential from the technical potential and feed that into local analysis of energy systems. And going back one slide, this can be done for up to 50,000 individual systems in Europe, and it's all available online already, except the cost curves. On the next slide, we will be looking at the third problem: how much excess heat from industry, from waste incineration, and from power plants that could be converted into cogeneration plants is available, and how much renewable energy sources are available, and which sources are within reach. So here we have done the following, that we have found the locally available renewable energy sources. For example, we based some of our data on the Biomass project, on the GeoDH project, and did some of the analysis ourselves. What we're currently working on is the allocation of excess heat across Europe to these 50,000 systems, up to 50,000 systems, in order to prepare local energy balances, how to cover the present heat demand with district heating, and how to cover district heating supply with available sources. So 3 problems or more can be addressed, and I want to show quickly through these things, to these processes on the slide. So the floor areas leads to the heat demand densities. We map, apart from rural heat demand, the heat demand in coherent systems. We calculate the supply investment costs. We create local cost supply curves. And this is then the basis for heat supply strategies in rural areas, which is pretty simple because it doesn't involve district energy systems. We then formulate heat supply strategies for urban areas on the basis of a least cost allocation of available excess heat to other areas. And this comes from mapping of renewable energies, of excess heat activities. So we are able to map the residual heat supply that has to be covered from other sources. Now, what are the consequences for cities and towns? And in order to make this a bit more relevant to the current session today, the energy transition that we're looking at is a deep intervention with current practices. So we have to change everything what we're currently doing. There's an overall and a long-term implication, and these must be known before making decisions. And we can only do that if we know the full potential, if we know the long-term implications. The success of an energy transition will depend on a full survey of choices for action and of their consequences. And here, PETA is just the very first step in this direction. I would be happy to show you PETA if we have the time to do that after the presentations. Meanwhile, I would like to show you the link to PETA. It's available from the homepage, and I would like to thank you very much.
Thanks a lot, Bernd, for this very concise presentation, I would say. It's always interesting to hear new news from Heat Roadmap Europe. And indeed, if we have some time afterwards, after we are through all the presentations and have answered the questions that are already coming in, we can see if we have time for showing PETA live. But now I would actually like to jump again to the first project we talked about, PLANHEAT, which is basically an application of the challenges that Bernd just presented, because PLANHEAT is developing a tool for cities for heat mapping and planning. And Peter will introduce us what is currently done in terms of research and how far the mapping tool already is, because he will introduce us to the mapping, heating and cooling demand and supply sources at city level. Please, Peter, the floor is yours.
Okay, thank you. I just need to accept showing my screen. Yes. Slideshow. Okay, thank you. Today I will talk about the PLANHEAT project. For those of you who are not familiar with the project, first the rationale, why mapping. This was already introduced by the previous speaker. This is a paper that I show you of the submissions of the member states under Article 14 of the Energy Efficiency Directive. And member states were asked, what is the projected share of district heating in the future in your country? The main message behind this slide is that results that came in were quite inconsistent. Even for the different regions in Belgium, different results were obtained. And the main message here is that national as well as local authorities, they have a lot of questions on how to decarbonize the heating and cooling demand. So we had a very nice first presentation, introduction of a city. So they have their sustainable energy action plan. And the question there is, how do we go from this action plans to a practical implementation and reduction of the CO2 emission? How does a PLANHEAT project come into this picture? Well, the main mission of the PLANHEAT project is to support these local authorities by offering them an easy-to-use tool for the mapping and also the planning of their heating and cooling decarbonization efforts. Today I will talk about the mapping, the demand and the supply sources as well. And also the next speaker will talk about this topic. The consortium, the overall project coordinator is Da Polonia, is RINA Consulting, as it is called nowadays. And special about our consortium is that we have validation cities included. So we already heard the city of Lecce. We also have Antwerp and Velika Gorica in Croatia on board. And those cities supply us with the data we need to see the approach we follow. Does it make sense? And would it also make sense for cities who have less data available? So very important in the project is that if cities don't have detailed data to support detailed simulations, that values are offered by default to them. So an overview of the tool itself, the module itself. To the left, you see the mapping module for which Vito is responsible. It consists of 3 parts. First, mapping the demand and supply as well. And very important is that aside from only mapping, the PLANHEAT project will also be able to do planning and simulation. So after the heat demand and supply is visualized on a map, there will be a tool attached to it so the cities, the local authorities can draw KPIs, can see where would be the ideal location for district heating network, also coupled to hourly simulations that perform a cost optimization. So in scope, it's really, it goes into detail. And the idea is that at the end of the project, end of 2019, the cities would be able to save money on a first feasibility study, a very high level feasibility study over their city to see how to start with implementation on renewable energy for covering the heating demand. So today I will talk about the top-down mapping, which is only needed a few input data. And this is the difference with the next speaker, Shabat. He will talk about the bottom-up mapping. And this is the case where cities have more data available, detailed cadastre data, which is not always the case. As the previous speaker also mentioned, a problem is often this data availability. So therefore, we offer also the option to cities who don't have all these data at their availability. So, how does the tool look like? Here you see a screenshot of the tool, where you see the beautiful city of Antwerp, and the input data that are needed for this tool are given here. Space heating, hot water, space cooling for residential and tertiary. If cities don't have these numbers available, a suggestion can be made to visualize, to spread the energy demand, the heating demand on the map. So the software used is QGIS. It's quite easy to use, the tool. So you just click what you want to see here, press run, and then you get an image like this, visualizing where is the high the high heating demand in your city. Next, another option is to select a specific district in your city. So here there is a polygon tool which the cities can see. Like I would examine how a detailed heating and cooling plan for this region. For example, for Antwerp, it was a certain region which we're interested in, and this is also important that the city can, in a flexible way, operate this tool to visualize demand and supply. And what they get if they select and run the simulation, they get here an image like where they visualize what the space heating demand, the hot water demand, and the cooling demand is. So this is important to them that they can, for all these districts, all these areas represent a different district. They can go district by district and seeing what is the heating demand there. Now for the supply, the next part of my talk, I will talk about the supply, but the supply is not yet fully integrated into the tool. This is work in progress. What are the sources that are mapped? Those are listed here. Solar thermal, biomass, deep geothermal, also industrial waste heat from power plants, and also the less conventional sources, like data centers, which are an emerging source of energy demand, supermarkets, subway stations. These are less conventional sources that can also be mapped and that can also be used to extract energy from. So PLANHEAT will make an effort to really provide the local authorities with information on how they can connect to these sources for covering their heating demand. An example, biomass from forests. This is already implemented in the tool. What we do is very similar. The approach is very similar to what the Heat Roadmap project does. We use European databases, and then from these European databases, we couple them to the local area. For instance, for biomass, you have the land cover map, the Corinne land cover data source. What we do is exclude the natural areas by default, and then there are in studies default values on how much energy can be extracted from forests if harvested for biomass purposes. Important to note is that cities can always override default values if they have better quality data at their disposal. So this is, I think, a very important point. So this is what it looks like in the region around Antwerp. You see the red areas, which are forest areas, which can be used for extracting biomass and then subsequently be used to decarbonize the heating demand in Antwerp. So for all these sources that I mentioned 2 slides ago, we will put these on the map as well. Another example is deep geothermal. This is a project, the GeoElec project, which already performed a lot of studies on deep geothermal, and they made a map of the underground temperature levels at various locations in Europe. So we use the data of this project to provide the first estimate of the city. Of course, this is not a detailed feasibility study, but it provides a first estimate. We use here their formulas, the available heat in the ground, the theoretical potential, the efficiency. Important is that we don't invent all these things. We use the data which are collected by other projects and apply them and collect them and apply them to the PLANHEAT case. So this is another example. The overall status of the project. At this point, we have first prototype of the mapping module. which I talked about, and the next speaker will also talk about. Currently, we are integrating the supply sources to the mapping effort, and a very big important part of the project will be the planning and simulation module, which is currently being developed and which can be expected later this year. And the planning and simulation model will really go into more detail, providing hourly simulations and allowing the city to cut costs on feasibility studies. Also, what I like to mention is that we organize a training on the mapping module, a hands-on training, and it will be the 8th of June in Brussels. So it's open to everyone. Registration is free. It's close to the European Sustainable Energy Week there. So if you're interested on this training and on this extended hands-on session, please send me an email. Thanks a lot.
Excellent. Thanks so much, Peter, for this presentation. Indeed, PLANHEAT has a big part about basically supporting cities in using this tool. So there will be other trainings, and I will present a bit more to you later on. But first, I want to hand over to Shabat, who indeed will speak about mapping current and future heat, cool, and domestic hot water demand at district level, to round off basically the latest research results from PLANHEAT and where the tool stands. So please, Shabat.
Okay.
The floor is yours.
Yeah, thank you very much, Sofia. Can you see my screen now?
Yes, perfect.
Okay. So during this last presentation, on the one hand, firstly, I would like to appreciate this possibility to present this development that we have done during this project of PLANHEAT. The presentation is going to be focused especially in one specific module or product or tool that we have developed into the PLANHEAT project. So we are going to focus the presentation only in one specific tool, which make possible to map and assess the energy demand for a specific area of the city or district. So this tool is focused in one specific issue. In this case, such as introduction, in order to support the energy transition of Europe to a low carbon economy, we feel that the municipality have a key role to play. So one of the first needs for our local authorities in the process of selecting and assessing future heating and cooling scenarios is to have within that a clear picture of the local framework in terms of demand and also the energy sources. In this case, according to this need, the entry point of the PLANHEAT platform will be the mapping module, a software dedicated to the visualization of information about local heating, cooling, and domestic demand. So in this case, Peter had presented the overall approach of the mapping module, but we are going to focus during this presentation only in this specific tool or in this specific application of the mapping model, which is the district mapping model. The district mapping module maps, quantifies, and stores the georeference heating, cooling, and domestic hot water energy demand per each area of the district or of the area that we have the end user has selected. This module applies the method, the assessment method bottom-up, which starting from different information of each building of the selected area, calculates the energy demand for all these different buildings. At the end of the presentation, I would like to show the example of the Amber, where we have assessed in a unique assessment process more than 1,000 2,600 buildings. So the process is going to be automatically possible to assess more than 2,000 buildings. Only to clarify, as Peter has explained it, that this district mapping module also is going to be part of the plugin of QGIS, which is a free and open source GIS cross-platform application. Maybe this is better to see. Okay. In this case, this is the overall approach of the structure of the district mapping module, where there are two main blocks. There are the inputs, which are important because according to the inputs accuracy, the results of this tool are going to be different. So we have the one block related to the input and the other block which has different steps in order to assess the baseline scenario, that means which represents the picture of the current energy demand status of the selected area, and also we have the possibility to assess different future scenario where the end user has the possibility to assess a future scenario defining different passive refurbishment strategies for buildings located into this area under study. I know that the future scenarios, they are not limited for passive strategies, but this plugin, this district mapping module is only going to be focused in order to propose these passive strategies. On the other hand, this tool, and also in the planning module, PLANHEAT will provide the possibility to assess and to integrate new active and renewable strategies. Which are the inputs that we need to assess one area or one district by this tool? There are 4 main inputs, and the important is that the main input that the end user should provide is a shape file with the following mandatory information. And this information is mandatory for each building of the selected area. This is, for example, this is the most difficulty that we are finding, because not all the municipalities has enough information to define each building. But we need the ID, a number, a codification for each building. We need the value for the height of the building, or also if they provide the LiDAR file of this area, it could be enough. And if they don't have the LiDAR and neither the height, if they provide us the number of floors of each area of each building, it could be enough. Also, we need the year of construction, and finally the use, which in this case, this use is the main use of the building, because we would like to highlight that this tool doesn't allow to differentiate between ground floor use and the use of the other floors, because we understand that there are a lot of buildings that the ground floor, for example, is commercial and the other building is residential. In this case, we have to select a unique use per building. And finally, there are another inputs that they are going to be defined directly by the graphical user interface of PLANHEAT. So after uploading a shape file with these 4 values, there is an internal data process of this shapefile, and automatically the tool assess and calculate these other 7 or 6 parameters, which are going to be used during the internal assessment of the district mapping module. And also, it is important that in order to carry out the energy demand assessment, this information is not enough, and we need more specific data. So, Technalia and this project, in order to automatize this process, they have defined a set of different inference rules linking the outputs of the data process section, this section, with the information obtained of several European databases and other sources like scientific papers or scientific publication. And which are these inputs? They are the schedules related for the occupation, heating, cooling, hourly schedules, also values for internal gains, U values, window to well radius. So these are more technical values which are directly related with the energy assessment. And here we would like to highlight that nowadays we have default values for all the countries for Europe, but in the case that the municipality want to integrate their own values because they have information about this area, for example, about the U values, the Planchet district mapping tool we can edit the default values and they can use their specific values in order to calibrate the tool for their case study. This is how is the energy demand assessment algorithm. It is only to say that we are based in a static algorithm which takes into account the heat in degree hours, the U value of the envelope, of the different elements of the envelope, the area of each envelope element, the roof, facade, opening and ground floor, and also in this case we take into account 21 degrees and 25 for heating and for cooling, and also we are taking into account the internal gains related with occupants, lighting and appliances, and also solar gains for each building. And finally, we take into account the ventilation losses for each building. So the assessment is for each building. So which are the outputs that we are going to obtain? There are two levels of outputs. So this district mapping model provides its results by two different scales or assessment levels, the building scale and the area under study or the district scale. For the building scale, this tool provides georeference, generic, and also energetic information in two different formats, the CSV and also the shape files. At the end of the presentation, I will like to show you which kind of results we are going to obtain. And which are the outputs. The one hand, there are the inputs provided by the municipality in the initial shape. These are the outputs obtained by the data process. And finally, there are the energetic results that we have obtained by the district mapping model, which are the annual heating, cooling, domestic hot water demand per each building, also annual heating, cooling, and domestic hot water demand per square meter of each building, and finally, we can obtain the peak power for heating, cooling, and domestic water per each building. So there are the information that we are going to obtain for all the buildings selected into this area. And also, in order to analyze the whole and have an overall perspective of the city, the district, there are another results for the whole area under study. And in this case, we can obtain the annual heating, cooling, and domestic hot water demand for all the area, and these results are going to be classified according to the construction period of the buildings and also to the use of the buildings. So we can have a unique value for all the area, or also we can analyze which are the demands, for example, for residential buildings which are built between 70s and 80s, for example. So we can have a specific information for each building, or also we can analyze the overall approach of the district. And finally, this is the last step that we are now finishing, and we are validating for, and we have started by validating with different cities. This is the possibility to generate the future energy demand integrating passive strategies. So into this is a screenshot of the plugin of the district mapping model. There is an option to generate different refurbishment scenarios with different thermal refurbishment levels, and also you have the possibility to select which kind of buildings according to their use or construction year you want to refurbish. So these are the possibilities that has the end user to define different future scenarios and compare with the results that we have obtained by the baseline result. And the outputs for the future demand, they are going to do the same. They are going to be the same like the baseline generic output, but we are going to have new energy demand results considering these refurbishment strategies, and also we are going to provide the result about which are the refurbished area in all these districts in order to know how many area is refurbished, and also which is the economic and environmental impact related to these refurbishment strategies. And finally, in 1 minute, I would like to show you how we have used this platform in one of the validation cases, which is the Antwerp District City. In this case, this is the QGIS. Here there is a plugin that we have developed into the PLANHEAT, and this is the district mapping module PLANHEAT. There are some inputs here. The end user provide the shapefile. We have to process some internal matchings in order to understand the information, which is the information provided by the end user, and we have to link with our internal some rules. But the results, the most interesting is that this is the result. This is the initial shapefile, where we can see that, for example, for one specific building, we have all this information, for example, the ID, the centroid, but here we have the demand for this building, also the demand per square meter, the cooling demand per square meter, the domestic hot water demand, and here the maximum power needed per each building. So, and additional information related with height, gross floor area, number of floors. So this is the results that we are going to obtain. And in this case, only to say here there are 1,000, I think more or less 600 or 700 buildings, and the assessment process, the duration, it costs less than 14 minutes. So this is the results that we are going to obtain, and also these results can be analyzed by a CSV file. Here are all the values for each building, and also we can analyze the results for the whole district. So we have the classification of residential building between classified by different period, and here we know the result, for example, which is the annual useful heating demand for this kind of buildings. And finally, for the whole city or for the whole district, which are the results, and we have the possibility to focus, for example, the municipality to focus the effort for refurbishing the buildings that they are built between this period, because they are the most critical buildings. We think that this kind of results could be useful for the municipality. So finally, I would like to thank you for attending, and also to say that in few months, I feel that we are going to have the possibility to present all these developed by a scientific paper. So if you need more information about the mapping module, or if you want to integrate this kind of tools in your city assessment process, so we don't have any problem to support you and to help in order to improve this situation of for the low carbonization of the cities. So thank you very much, Sophia, and thanks for all.
Thanks a lot, Shabat. Yes, very interesting presentation. And indeed, if it was too technical for you, for example, now, basically the aim of the PLANHEAT tool is that it's for non-technical people, so you do not have to worry about all the research that is done in the background. And there are training sessions that help you to basically use the tool. There is one question that is addressing what you have been discussing right now, actually. It's by Richard Bücheler. When and in which form will the PLANHEAT tool will be available? What is the target group, and will it be a QGIS module for planners in municipalities and cities? I think two parts of this question I can answer myself. So the target group is indeed cities and municipalities, but of course also urban planners that are working together with cities, or any consultants that are working on heat planning for cities. And as you saw, indeed, it's a QGIS module. Yes. And I let Peter and Shabat answer at what time we intend to have the tool ready for download, I suppose.
Yes, so now it's not the tool ready for download. Now we have the mapping module, the prototype is finished. However, we are still integrating the supply. So we have a working version available now, which is also being worked with on the training session. For the final publication of the tool, we need to discuss if we publish the mapping module separately. But I think by the next year, by the end of next year or half of next year, you will have the tool somewhere available online.
Yes,
Shama,
indeed.
do you want to
actually,
complement this, or?
the PLANHEAT project runs until next year, October. So that's kind of the cutoff point for delivering all the modules anyway. And indeed, the mapping module is almost finalized now, right?
Yes. So the mapping module will be finished by the summer, and we need to discuss when exactly we publish this module and how do we do it, because the planning and simulation module will be finished at a later date.
Yes.
Yeah,
Thanks.
totally
Shabat,
agree.
you want to add?
No, I would like to add that this mapping module is into the mapping module, so the product that we are going to present is together, so it depends. It's the same one, Peter, yes.
Okay, thanks a lot. Okay, so as I already announced, we will go through all the questions that you have submitted during the presentations, but please feel free to also add questions now, or if you would like to discuss any particular topic. So there are actually two more questions for Lecce. So I ask Serena or Francesca to answer them. The first question is, as a lot of measures target the electricity consumption, I'd be interested in the CO2 emission factor of power you used for the calculation of the emissions. Can you answer this question, or is it too technical and we take this offline?
No, actually, okay, it's really technical, but what we can say is that they are not mainly electricity. I mean, it's more because for heating, as I said, the main, let's say, source at this moment is the methane gas. So, and these are for mobility. So it's not mainly, I mean, it's not mainly connected to electricity. I don't know if that's one the answer that you are expecting, or if I should be more, you know. Hello?
Yes. Okay, thanks a lot.
Yes.
The next question.
I mean, I don't know if
sorry. Yes, go ahead, please.
No, I mean, that's the thing that, I mean, I have to, I can say that I'm trying to reach the bias, if I can give you more details about the energy sources that have been calculated. I mean, if I don't know, I don't know if I can get rightly your answer, your question, sorry.
We can also take this offline. So if Richard would send us an email, that we could answer this technical question like this. Okay?
Yes, what I can say is that the main, let's say, emission from the residential sector, because I have in front of me the bias, are from the natural gas, methane one. Okay.
Okay.
We have, okay, no, we have, yes, by the way, yes, I can provide you this information. Two, let's say, sources that are the cause of the CO2 emissions, that are, of course, methane gas and electricity. Yes, sorry, I did, I was wrong, because the electricity is 50%, the natural gas is around 40. Okay, responsible of the CO2 emission.
Okay, thank you. Yes, the other question is, and further, what are the incentives to install photovoltaics for the private households?
Yeah, at this moment there are not, because the incentives, they are used by regional or national legislations, you know. So at this moment, they are not at regional level. We don't have incentives for the photovoltaic, but we have for the solar collector at this moment. So private are like in some way incentivized by the region because they can install the solar collectors and they can be reimbursed by this effort in total. If they want to renew the plants that they have installed in their, let's say, houses. So for the solar collector, we have incentives, but we don't have at this moment photovoltaic. Because when the PAS was written, at that time, we had also for photovoltaic. But at this moment, I can say in these months, we have these incentives only for solar collector panel. Okay?
Yes, excellent. Thanks a lot for that. Then we have one question, and I believe it's addressing Berend. It comes from Simon Bike from London. How does this link with electrical demand in cities and allow a more integrated and smart energy?
Yeah, well, we do not map electrical demand, is a short answer. The smart energy link is, well, basically, traditionally, I think there has been a different scale at which electrical systems have been mapped, because in most countries we have a distribution grid and a transmission grid that covers all areas very well. So contrary to that, heat can only be supplied over shorter distances, and the infrastructure needed is much more dependent on the density of heat demands than the electrical demand. So we have not looked at electrical demands.
Okay, thanks. And I see that there's also a comment by Simon that they will organize a session at USEP about energy master planning, which includes electricity and heating. So we should come along if you're interested. Thanks a lot, Simon. Then there's another question addressing PLANHEAT. So no, we already answered this one about the QGIS model. Yeah, we have other questions on PLANHEAT from Yong Chen, namely for the mapping and supply modules, to what extent, if at all, energy efficiency improvements have been factored in, and how was it done?
Peter, I think that, yeah, in this case, as I have tried to explain, in the district mapping model scale, we are not going to take into account the energy efficiency of any energy system, but there is a specific screen or graphical user interface into the mapping module, which defines which kind of energy efficiency, but which kind of technologies are going to use to supply this kind of energy, but each kind of energy into the city. That means that, for example, if the end user said that the energy demand related with the heating is, I don't know, 100%, in this case, they have to define the percentage of the different energy systems that they are going to use to provide this energy. So, for example, 40% is biomass boiler, another 50% natural gas boiler, and 10% heat pumps. And in this case, the end user should define the energy efficiency of each boiler or each energy generation system. We know that this value is very general for if we want to assess the whole city, because there are several different energy efficiencies for each of these energy systems, but we need to define one value. In this case, there are some default values, and the end user, if they have more detailed information, they have the possibility to edit this default value. But maybe, Peter, that you have the overall approach of the mapping model, you can add something.
Yes, this just to complement this, taking into account all future scenarios, energy efficiency, and all these technologies you explained will be done in the mapping module. So this is still in the planning module. Sorry. So this is still a work in progress, and this is to be expected at a later date. Okay.
Okay, great. Then there's one last question, Peter, for you about the training session in Brussels. So if you could explain maybe a bit more about the content and the format, and I will then add about the opportunities to use the e-learning platform and other webinars coming up.
Yes, if you want, I can also forward the official invitation or the official agenda of the training session. The first part will be an instructive session, which is a training on what are the regulatory relevant points on heating and cooling, what are the technologies, what are the questions local authorities have, and then the training is from 10 to 3 in the afternoon. So in the AM there's an instructive session, and then PM from 1 to 3 there's the hands-on session, which is going to use the tool. It's QGIS, but it's the software. Everyone should be able to use the tool and software. We will also train the local authorities to download a map of their area for cities that are not used to this, and to visualize their heating demand from the beginning. So this is the content of the training in June. Please send me an email and I will, or send the organizer of this session an email, and I will forward you the detailed agenda.
Great, excellent. We will also announce this event on the PLANHEAT website shortly. So you can also just sign up to the newsletter there, or keep a look on the event section on the PLANHEAT website. So thanks a lot, Peter, for that. And indeed, I wanted to tell you a little bit more about the training opportunities for cities in the PLANHEAT project, because basically the aim is to have 50 cities trained in PLANHEAT, and there are overall 25 training sessions organized in different EU countries throughout the project. And yeah, as you already mentioned, there is one hands-on training session coming up in June, on the 8th of June. And there are usually webinars organized for different regions, because we have regional experts. We have experts for Eastern Europe, for Northern Europe, for Southern Europe, and basically for Belgium, and also some for the Balkan region. And they're organizing webinars regularly for each module. So the first module, namely the data that has to be made available for using the PLANHEAT tool, and where you can get these data sources for the mapping, has been carried out already last year in September, and there have been new training sessions going on now in April. There's one last webinar taking place for Eastern European cities, but please feel free to also connect to it if you're from another region, and it will be announced on the website. And the future training sessions are also announced on the website. Yes, and you can as well sign up to an e-learning platform on the PLANHEAT website, where we have basically a forum area, a lot of hands-on trainings, some real input sessions, and then you have a quiz at the end. So it's an interactive e-learning platform that is complementing basically the webinars. And Michiel, who is connected for representing the northern cities, he said that on the 19th of June there will be a webinar for Northern Europe, and it will be in English. Voila. Now we have still some more questions coming in. So there's another one on for Peter and Shabbat. Following questions: is the energy efficiency measures that end users will take in order to reduce the consumption? This would affect the demand assessment, wouldn't it? How would it be handled in the module?
Peter, because it's when we talk about energy efficiency, as Peter explained previously, it's going to be part of the planning module. So maybe in this moment it's under development. But maybe Peter, do you want to add something?
Well, yeah, indeed, the energy efficiency. This will actually be yes, it will be part of the planning module, and a lot of these things need to be specified by the user. And the energy efficiency measures, I think, Shabbat, it is more a question for you, because I explained to you the difference in the top-down procedure, which works with very little data but provides a first estimate for the city. There we cannot go into the details of the buildings, but then we have this the bottom-up mapping module, which Shabbat talked about, which uses detailed building information. So maybe Shabbat, you can answer this question on energy efficiency.
No, I understand completely the question. The problem is that the scope of the module, the scope of the current version of the current module of the district mapping module is limited to obtain the energy demand, and the demand is not related to any energy system. The demand is according to the building characteristics, for example. So in this case, the second step, the next step in order to analyze this demand is related to which kind of energy systems we are going to use to supply this energy demand. So in this case, into the PLANHEAT, it is not going to be assessed by the district mapping model, and it is going to be assessed by the planning model, which I hope that it is going to be presented in a similar presentation. But I know that it's something for us, something interesting, and in other projects we are trying to insert the energy system for each building. That is correct that in PLANHEAT it is not integrated still, and we are not going to also integrate it, but we know that, for example, databases like Tabula, they propose several, they have an interesting database with different building types and different building construction yard ranges, and there are some default values related with energy performance or energy efficiency for each kind of building typologies for each European country. So our proposal is focused in this line to develop a database with all the information of Tabula or a PSCOP, this is a similar project, and automatize all this process in order to say only we have a building located in Italy, and it was built between 70s and 80s, and it is a residential building. So we automatically define a default value with energy efficiency, and we can obtain the consumption. But nowadays, we are going to limit in PLANHEAT only to obtain the energy demand. So we don't need the efficiency.
Okay, thanks a lot. I think that answers the question. I have one more comment by Simon about the separation of heat and power mapping and that it is a barrier to deliver district heating networks in cities, as they need to provide support to the wider energy system, including the relationship between cities and national systems, and not just thinking about supplying heat to buildings, as otherwise individual solutions will continue to compete with system-level systems. Yes, I think we will take this comment on board, and I just want to add that basically, besides the 3 cities that are part of the PLANHEAT project, Lecce, Velika Gorica, and Antwerp, we also welcome other cities to provide us with feedback, mainly during the training sessions, but any other events, of course, as well. So please stay in contact with us. We want to provide a tool that is as useful as possible for you. I am not sure if we can really promise to include electricity and heating in this tool, because it's a heat planning tool that we develop here. All right, I think we still have 5 minutes. Bernd, what do you think? Do you want to show the PETA Atlas online? Does it make sense in 5 minutes? Bernd, are you still with us?
Yes, you have muted me. Okay. Now I can give a very brief account for PETA. If you share my screen, please. Not that one.
Yes.
Okay. Which screen are you seeing right now?
We see the PETA Atlas.
Ah, that's good. So, well, let's just jump into the lecture that we have seen before, and just to see what PETA can do. This is the heat demand in current heat demand in 2015 in the area. We see that Lecce indeed is located close to the sea. It has some neighbor cities, some neighbor towns. We see the heat demand mapped at 100-meter resolution. But if you look into the local level, you will notice that the layer disappears, and this is practically for reasons of the amount of data that we have to convey here, but also not to give the impression that actually we can do local heat mapping with PETA. What we can do is to see what are the supply opportunities. For example, we can check if there is a system in place, a district heating system, one of the 5,000 or 6,000 district heating systems that already exist in Europe. There's none. But we can see if there is a prospective supply area where we may develop district heating in the future. And indeed, there is one in Lecce, and you can get some accounts for that, the heat demand summarized by densities. And now heat demands above 120 terajoules per square kilometer are already feasible today. And if we extend that a little bit, we can also include the ones 50 to 120. And from this figure, we can see that out of the total heat demand that we have calculated to be 1.8 petajoules, 1.2 petajoules could be future district heating. We can also see where the heat demand should come from, and one could be geothermal heat, very, very attractive in Italy indeed. We can see different data from the GODH database. Let's see if there's anything around. Yes. The area is in a so-called neogene basis. That means that there should be some geothermal heat in the bottom. We can look at the obvious solar thermal potential here, and this has been mapped for different cities around Europe. I'm not so sure if it is mapped for the city of Lecce. In this case, not. We have access to biomass resources on the local to regional level from the BioBoost project. We have excess heat activities. For example, here is an excess heat facility a thermoelectric power plant in Brindisi, which could provide a lot of waste heat on a yearly basis. Meanwhile, we see that the biomass potential is available in the area. For example, we have straw, we have pruning residues, there's a lot of orchards in the area, there's not much forest, and there's organic household waste that sums up to 3 petajoules of biomass waste in the area. We can also see how the region does in terms of, oops, I'm gone, how the area does in terms of being attractively located for the use of excess heat and the development of district heating systems in the future. We have mapped the so-called heat synergy regions. Here, the area around Lecce deserves a score 2. That means a high potential, a high priority for looking into opportunities to develop district heating and to utilize excess heat from industry. That's a very short overview of the current system. What we are currently working on is an update. We will be looking into energy efficiency measures. We'll be looking into the allocation of excess heat resources, as I've mentioned before, and we will improve some of the mapping activities that relate to biomass and some of the other renewables. Okay, that's a very short walkthrough.
Thank you very much. There are 2 quick questions that we can still answer on PETA. One is coming from Michael Fremau. How complete is the data set? I noticed that San Cataldo seems to have 0 heat demand. So he's asking about about the data gaps that you might have in them.
We have a top-down model, and if some areas are missing, I don't know. San Cataldo, is it? Where is that located? It's not even on my map. Excuse me, for my ignorance, I don't know where that is located.
It's without the N. It's San Cataldo. Comune di Lecce, on the coast, apparently, very, very before.
There's one word, San Cataldo.
It's without the N. No November in there.
Cataldo.
Yes. And it's probably 2 words.
Yeah. I do have a heat demand here, but if you zoom in more, it will disappear, right? And it is simply because we cannot be confident that that our map is so precise that we can do very small studies. It's part of the prospective supply areas, so we actually can get an account of the area of the heat market. So San Cataldo is included. Basically what we do is we map all areas that are built up in Europe. So whenever the European Environment Agency and the JRC have indicated that there are people living and there are houses around, then we map heat demand. But we exclude those areas where heat demand is very, very low. And this is not visible here. We do have a further level of heat demand density that is visible on the account, everything below 20 terajoules per square kilometer. We cannot map it because it's a very large data set, but it is definitely included in our statistics and in our mapping of heat supply opportunities for rural areas.
Okay, thank you very much. Apparently it's not this San Cataldo, but I think in general we have answered the question about small municipalities. There's another question I think that you can quickly answer. Are all operational layers available on PETA online?
No. So this is work in progress. We have a front end and a back end, and the front end is what we see on PETA online. The data is also available through ArcGIS online for ArcGIS users. We're thinking of making it a bit more open still, at least some of the layers. There's also a huge back office where all the data is managed by the handful of experts that work with it.
Okay, great. Thanks a lot. I think this only leaves me with thanking all the panelists and also all the attendees for the interesting questions and comments. I hope you found it useful. The webinar will be published on the Celsius Wiki, which is available for Celsius supporters and Celsius cities. So if you're interested, you can, of course, also sign up to become a supporter. Yes, and please stay tuned for the next webinar that will be organized in May. And I believe it's about the FET project that Gothenburg city is currently participating in about the local energy markets. So thanks a lot and see you soon.